Hello, this is Coach Meidenbauer here for AP PreCalculus. We are on 2.8, inverse functions. Inverse function, everything is up here in the notes up here to the right. Inverse function, you can read about it. Some mathy words here like invertible and stuff being mapped from input output. Essentially what it is, all we're doing is just reversing where our x's and our y's are. We can use the verbiage even, like we're just switching x's and y's, and that's it. Okay, so inverses can only occur, by the way, if the functions are one-to-one. For our purposes, what we need to know what that means is the function has to always be increasing or decreasing. Otherwise, it's not one-to-one, and the inverse would not exist because it would not pass the horizontal line test. Okay, a quick little note right here with properties is that if we take a composition of the inverse and the OG, the original, we should just appear with an x. Okay, so couple examples here with inverses. This is a parabola. Actually, this is a parabola I got cut in half because, as you can see here, we have f of x is 2x squared plus 1, and that is for when x is only bigger than 0. What's the inverse of f? So all we're going to do is we're going to reverse the x and the y. So all we're going to do is this becomes x equals 2y squared plus 1, and we're going to solve for the y. So subtract both sides by 1. Divide both sides by 2. Okay, I'll put the y on the other side and square root both sides. So we got y equals plus and minus square root of x minus 1 all over 2. Now, that's the math work, the analytical work, but I want to graduate this to an inverse. This is not an inverse, so I'm going to graduate it with a notation. And take note here that since x is positive the entire time, that for my inverse, it's going to affect it a little bit where we can only have positive y values. So I'm going to reject that negative and just have just the positive square root of x minus 1 all over 2. Okay, so because of this restriction of the x being greater than or equal to 0, this does work. Also, please take note that x has to be larger or equal to 1 for this to work. Otherwise, the domain is limited. So it's kind of nice to put those restrictions when you do inverses, just so we can get a clear picture of what's going on. Very similar problem here, where we just have the equation. So the same steps here. We're going to switch the x and the y, solve for the y, see if it graduates to an inverse or what values do. So this becomes x equals 2y over y plus 1. To solve for y, I'm going to multiply both sides by y, so I get x times y plus x. All I did was I did x times y plus x times 1. I just distributed right in that one step. Let's get all my y's on the same side. So I'm going to get 2y on the left side equals negative x. That way I have a GCF of y's. Okay. And then from here, you can go ahead and divide that x minus 2 over. And there is a limitation here for this inverse. So let's go ahead and graduate this as an inverse. And our only restriction we have here for domain is that x cannot be 2. Okay, there is a restriction from the original here where x cannot be negative 1. But our restriction for the inverse is that x cannot be 2. All right. So I'm going to kind of leave this composition of inverses that I boxed available here. So this is important for example 3. We're going to show that f and g are inverses. In order to do that, we're going to show the composition of both of them and make sure that they both are equal to x. So what I mean by that is I'm going to do f of g of x and show what that equals. So I'm going to take f and plug in g, which is actually right above it, which equals, now I'm going to rewrite f, but instead of x, I'm going to write 3x minus 1 over 2. 1 all over 3. So all I do here is just a little canceling out. Those 2's cancel out. And I get 3x minus 1 plus 1 all over 3. The negative 1 won't cancel out, so we get 3x over 3, which is just x. So far, so good. Looks like these are inverses. I'm going to require that we do look at both of them, both compositions. So if we do that, we're going to get g of, and now the f value is 2x plus 1 over 3, which means I'm going to rewrite g now. But instead of x, I'm going to write down this 2x plus 1 over 3. So all over 2. 3 is going to cancel out, leaving me with just 2x plus 1 minus 1. All over 2, and this is looking good because we're going to get an x. Okay. Oh, tables. Oh, this is easy. This is like Algebra 1 stuff right here. Table gives values for the invertible function y equals f of x. Write the table of values for the inverse. Okay, so this is saying that we can. That's what the invertible means. It means that hey, an inverse does exist here. So all we're going to do is we're literally just going to switch our x's and y's. So for the first one, we're going to get negative 11, and then we're going to get negative 3. Next one, you're switching it. Switch it. Switch it. Switch it. And switch it. Just double check because it is kind of a mindless task here just to switch the x's and the y's, but just go ahead and check your answers. For some reason, if I made an error, just let me know in the comments and then I will fix it. Last thing here is doing some graphical representations. Please take note that the inverse is symmetric along with the line y equals x. So if I were to draw the line y equals x, then this function right here would have the mirror image of this being flipped over. Okay. I do have these graphs down here. For this one, I will just draw it on here just because I want to show you this. So if I have the point 20, that turns into, sorry, if I have the point 02, that means I want to graph the point 20. I have the point -4, -2, that means I want to graph -2, -4. Boy, let me try that again. -2, -4. Okay, so this graph looks something kind of sort of like this. Now, my graph doesn't match this perfectly, but you get the idea how the blue and the red can just fold over the line y equals x. Okay. So this one I want you to sketch the inverse and then name the domain and range of the inverse function real quick. I will talk about this function. Let's go blue here. The domain of this function right here is going to go from -4 until 2. Those are my input values. My range is going to go from -4 to 0. Okay, as I'm sketching, and I'll sketch my inverse red down here. I'm going to switch all these points. So instead of -4 is 0, I'm going to have 0, -4. Instead of the point 0, -2, I'm going to go -2, 0. And instead of the point 2, -4, I'm going to go -4, 2. Okay. So now I'm not going to just connect these points randomly. I'm going to kind of see what's going on with the shape of this and stuff like that. So from -4, 0 to 0, -2, that was just a straight line. So let's go ahead and connect that straight line. And then for this next one right here, where it looks like we got a little bit of like a parabola action going on for that one right there. Trick for this one is I want to go over the domain and range now with the inverse. So this domain is going to be from -4 to 0. This range is going to go from -4 all the way up to 2. If you notice here, my domain and range from the inverse in the original are switch. So again, inverse is switch. This is the x and the y's, which is the input, the output, which is the domain and the range. And that is going to wrap up our video here for 2.8 inverse functions. I'm Coach Meinbauer. Do not forget to like and subscribe.